Common factoring. We have here our polynomial. It has two terms. When we're looking for common factors, we're looking for a number that is divisible by both terms. Okay? If we have more than two terms, maybe we had three, we'd be looking for a number that's divisible by all three terms. In this case, we're just starting with two. What we're going to focus on to start is the coefficient, which is the number in front of the variable. Okay? I got to look for a number that is divisible by both. If you can't see it right away, the easiest way to do this is to set this up on the side and write the factors of both terms. For 5, we have 1 and 5. For 20, we have 1, 2, 4, 5, 10, and 20. Okay? Then we're just going to look for the greatest common factor. 1 is obviously a factor of everything, and 5 is a factor of both, so that is the GCF, the greatest common factor. So we're going to divide both terms by at least 5, and then we look to the variables. Okay? We're going to write out what these variables consist of. X squared is essentially x multiplied by x, and the value of x is just x. What we're going to do is pair up as many as we can in each. Now, in the first one, obviously, there's only one in each we can take. We cannot take 2 because there isn't a second one to take when we have x to the power of 1. So, the term we're going to divide by is 5x. We're going to divide both terms by 5x. Now, we're not dividing both sides of the equation, if you notice. What we're doing is we're just taking a value out of this, and this is the opposite of what we did the other day, where we're doing distribution. Okay? So what's going to happen is this 5x is going to come to the outside of a bracket. And then we're going to set up a bracket. And because we started with 2 terms, there should be 2 terms within the bracket. And we're going to figure out what those terms are by dividing these values. 5x squared divided by 5x will give us what? Just x. 1x, or we can just put x. And positive 20x divided by 5x? Positive 4. So this is the opposite of what we did before. Before, we were working on distributing these values. So if you wanted to check to see if you had the right answer, you could multiply both values by 5x, and you should get what we started with. What we did instead is we took that same common value to the outside, and that is our common factor. So here's another example. We have 3 terms in this one. Again, the first thing we're going to look at is the coefficient in all 3 of them. What would be the greatest common factor of 12, 18, and 24? 6, that's right. So if you wrote it out on the side, 6 would be the value we're going to take out of all of these. Now we have to make sure there's a variable involved in all of these. Is there a variable in each of these?
Yes.
Okay, so since there is one, that means we can take a variable out. Okay, what variable are we going to take out?
3 or 2.
That's a 3. Okay. So we're going to take out just the value of x from each. So we're going to divide every term by 6x. 6x will come outside of the brackets. And inside our brackets, we'll then have 3 terms, because that's what we started with. Okay? And those 3 terms are going to be what these are when they're divided. So 12x cubed divided by 6x will give us what? 2x squared. Good. 18x squared divided by 6x? Positive 3x. And 24x divided by 6 plus 4. Okay? That's it. Here's our third example. Now, in our third example, we have a number multiplied by a bracket and another number multiplied by a bracket. Now, remember, this is technically, because it's multiplication, 2 terms. It's our addition signs that separate our terms. Now, if we did distributive property, we could easily make this into another 2 terms, okay? I want you to see it right now as just 2 terms, and there being a common factor in both. We're going to set this up and split it. We're going to do it 2 different ways. There we go. And what we'll do is, on the right, we'll do it the normal way. Sorry, that's the left. And on the right, we're going to use a let statement. The reason we're going to do this is so it's easier to understand doing it the normal way. So I'm going to rewrite it here. F at x is equal to 7x, x minus 3, plus 5x minus 3. I'll rewrite it on the other side too. And we're going to start with the value with the let statement. Right now, this is difficult to see. If you guys notice, both brackets are what? Anyone know? They're the same value. They're both the same value, right? So what we're going to do in the let statement to make this a little clearer, I'm going to say let y, let's say, because we already have x values, let y equal x minus 3. So then what we're going to do is replace the x minus 3's with the letter y. So we'll get 7x multiplied by y plus 5 times y. Now it's a little easier to see for common factors. Is there a common factor between 7 and 5? Just one. We don't really need to take one out. Is there an x in both? No, so we can't take an x out. What can we take out for both of them? We can take out the value of y. So we're going to use the common factor of y in this question. Okay? So when we do that, we'll get f. Oops. We'll get f at x is equal to y. And what will be on the inside of our other bracket? 7x plus 5. But we didn't start with y in this question. What was y originally equal to? So we need to put that back in our final part. So f at x is equal to x minus 3 times 7x plus 5. And this is our final answer. Our common factor was this bracket. So, with that being said, let's think of it now. If I were able to see that this was the common factor, I would divide both terms by x minus 3. Okay. The x minus 3 would come to the outside of our brackets. We'd have x minus 3. And inside our other brackets would be the other two terms that are left. Well, because x minus 3 divided by x minus 3 cancel each other out in both terms, what are the two terms that are left in the other bracket? 7x plus 9. And if you notice, our answer is now the exact same as we did with the let statement. The let statement just took a little longer to do. It made it clearer for us so that we could solve that question.